today we will discuss one of the important component that are nowadays is used for the energy storage. What is it? That is the basic electronic component for the storage of the for storage of the energy. So this component is the supercapacitor. So we discuss the supercapacitor. What is a supercapacitor? As we know that the capacitor is a pair of the two conductors of any shape which are separated through a small distances. So if we talk about the capacitor, then we always says that it is a pair of the two conductors, and they are separated through a small distance and in a close proximity and have equal and opposite charges. In other words, we can say a capacitor is a device that store electric energy. So a supercapacitor is also a type of capacitor, but its capacitance value is much higher than that of the other capacitor. That is why it is called a supercapacitor. So in general terms, supercapacitor is having the higher capacitance, and that is why it is called a supercapacitor as compared to the capacitor. So a supercapacitor is a specially designed capacitor which has a very high capacitance. So capacitors combine the properties of the capacitors and the batteries into one device. Battery, why we use a battery? Just we use a battery for the storage of the energy, and that we can use later. Similarly here we use a supercapacitor that will combine the properties of the capacitors as well as the batteries in the one device. So it is used for the storage of the energy. So in this presentation we will learn about what is a supercapacitor, types of the supercapacitor and its working principle, how it works. We will also learn about its application, its advantages and disadvantages. So first we start with the definition. What is a supercapacitor? Supercapacitor is an electrochemical capacitor that has high energy density. How we define it as it is a electrochemical capacitor with the high energy density, better performance efficiency as compared to the common capacitor and having a high capacitance. So the reason why it has prefix the super attached to it. Super, why? It is having a high efficiency and it stores and releases energy by reversible this is used as release energy by reversible desorption as well as the adsorption of the ions at the electrolyte interface. It means supercapacitor have the electrode and electrolyte in a single unit, and that is why we can do the desorption as well as the adsorption of the ions in the supercapacitor. Means we can charge and discharge capability in this supercapacitor. So conventional capacitor have the two energy density, the supercapacitor have the low energy density with the wider cell voltage and higher specific power. On the other hand, supercapacitor have the high capacitors over a lower limit of the cell voltage. So this supercapacitor are a new type of the capacitor and it is also called as a ultra capacitors. The characteristics of the supercapacitors gives them a high capacitance than that of the conventional capacitor. Supercapacitor have a high power density, but they suffer from the low energy density compared to the batteries. But however, recent advances in the carbon based materials, that is mainly we use the graphene, increase the energy density to nearly the level of the batteries. Nowadays the research is going on in this field, so that we can increase its power density and low but how we can increase the power density, as we use the one of the material, that is a graphene, just to increase the energy density for which is nearly to the batteries. A supercapacitor is a modified capacitor, and one modification is the electrode is coated or made of a porous material. Why we will take this as a porous? So that we can increase the efficiency. Being porous increases the surface area without changing the size of the capacitor and allowing it to hold the more charges. As it is a porous, so it is having a power to attract the more electrons. So it is used and by, if it is a porous, then it is a capacity to hold the more charges. So supercapacitor make use of an electrolyte also, that is a substance made of positively and negatively charged particles. When the electrodes are charged, electrolyte polarizes according to the charge of the electrode. So the separation of the charge creates the two opposite charged layer, so that acts like the new charge plate, and these four plates act like the two conventional capacitor attached in a series. Now these capacitors have a plate separation distance that are in the few nanometer in the thickness. So you on the screen that this is the basic representation. You are seeing here that here we are using the electrolyte between the particles. Current collector is on the one of the side here. Separator is used, that are the two electrodes that are separated from a distance. Now you see this is a substrate, that is the electrode which we will use. The combination of increased surface area and a small plate separation distance increases the capacitance and the energy storage in the supercapacitor. So the cross section of right shows a separator between the electrodes. The separator stops the electrodes from touching and shorting the circuit. Now you see on the screen that you are having the charge distribution in an electric double layer capacitor when it is charged left or when it is discharged, which is the right. You see here, once it is charged, when it is discharged. You see when it is charged, you can see that the positive electrodes attracted the negative electrodes. Here the negative electrodes attracted the positive charges. There is a separator, you can clearly see the separator between these two. That separator is the electrolyte. You see on the both side we are having the electrodes, and these electrodes having the middle separator. That separator is the electrolyte. When it is charged, that is a electric double layered capacitor, and it is charged, you see here, attracted by and when it is discharged, then or detached from the electrode, and they are moving towards the separator. Now we structure of the supercapacitor, you see here, there we are having a porous electrode. Why we are taking the porous? So that it can attract the more electrons or the charge carriers, so that it can work efficiently. So now we use the porous electrode, and it is a double layered, so it is a double layered charge capacitor. So discharge done, we are having a positive terminal, negative terminal, and we put the power controlling unit, external grid we will use. A separator we are using, you see on the screen, that is a separator, and that separator is the electrolyte. Now you see how the charge is flowing. This is the structure of the supercapacitor. Supercapacitor are made of the two electrodes. an electrolyte and a porous membrane separator. So, this specific structure of the supercapacitor makes them have the feature of the conventional capacitor as well as the electrochemical batteries. So, nanomaterial based supercapacitors are used to increase the electrode surface area so as to achieve the high performance and enhanced capacitance. So, what we use? We use a nanomaterial nowadays. One of the example is a graphene that is efficiently used to increase the electrode surface area so as to achieve the high performance, and we can enhance the capacitance or capacity. So, material or what material we can use for development of the supercapacitor? As previously we said that we use the porous material for the development of the electrode. So, the popular material to use for the supercapacitor electrode is the carbon. Carbon is easily absorbed charge carriers, and it can be the form of the graphite, it can be the carbon nanofibers, it can be used as a activated carbon, and recently it is used as a graphene. These materials are electrically conductive and have or can be engineered to have the porous surface. Means by using the graphene we can make it's a more porous, and which allow them to store more electricity. If it is a more porous, then it can store the more electricity. So, we try to synthesize the material in such a way so that we can get the more porous surface in the material and we can store the more electricity. Supercapacitor can be used a variety of the electrolyte solution. So, these include the acidic, alkaline and organic electrolytes. Alkaline and the acid electrolyte generally achieve higher specific capacitance, wherein an organic electrolyte are capable to sustaining a higher operating voltage. So, various type of the electrolyte we can use and all having its ability. So, these what we have the acidic, alkaline, we have organic electrolyte. Alkaline and acidic electrolyte generally achieve the higher specific capacitance, while the organic electrolyte are capable of sustaining a higher operating voltage. Now, what are the characteristics of the supercapacitors? Now, which are the basic characteristics that can be in mind just for development of the supercapacitor? Supercapacitor have the charge and the discharge times comparable to those of the ordinary capacitors. So, we have to keep in mind the charge or discharge time. So, it is possible to achieve the high charge and the discharge current due to their low internal resistance. So, charge time is one of the characteristics of the supercapacitor. Batteries usually take up to the several hours to reach a fully charged state. We can take a good example. So, we want to charge it so quickly and discharge. As a good example as for the battery, there is cell phone battery, while supercapacitor can be brought to the same charge state in less than the 2 minutes as compared to these batteries. So, the next point is the specific power. The specific power of the battery or the supercapacitor is a measure used to compare the different technology in terms of the maximum power output. So, the power output is divided by the total mass of the device. So, supercapacitor has a specific power 5 to 10 times greater than that of the batteries. So, how we can take the specific power of the battery or the supercapacitor is measured using the compare the different technologies in terms of the maximum power output divided by the total mass of the device, and we can find out the specific power. And the specific power of the supercapacitors are more as compared to the batteries. For example, if we take the lithium ion batteries, which is having the power of the 1 to 3 kilowatt per kilogram, the specific power of the typically supercapacitor is used the 10 kilowatt per kg, and this property is especially important in application that require the quick bursts of the energy to be released from the storage devices. The other point is the cycle life or the safety, that is the most important part of this supercapacitor. The supercapacitor batteries are safer than the ordinary batteries when mistreated. Like while batteries are known to explode due to the excessive heating, then the short circuited supercapacitor do not heat as much due to their low internal resistance. So, these batteries are safe. So, supercapacitor are the safe as compared to the other batteries. Why? Because it is having a low internal resistance. Next, shorting a fully charged supercapacitor will cause a quick release of the stored energy, which can cause electrical arcing and might cause the damage to the devices. But unlike batteries, generated heat is not a concern in this case. So, supercapacitors can be charged and discharged millions of times and have a virtual unlimited life cycle. Means we can charge, we can discharge, we can charge and discharge the supercapacitor. So, we can have the millions of times we can do it, charging, discharging. Moreover, they have the virtual unlimited life cycle, while batteries only have the cycle life of the 500 times or the higher. So, they make supercapacitor very useful in applications where frequent storage and the release of energy is required. So, supercapacitor are of many types that we will discuss. The types of the supercapacitor. Supercapacitors are referred to as the gold capacitors, power capacitor, ultra capacitor or the supercondenser. So, on the basis of their charge storage mechanism, they are classified into three types. Number one is the electrostatic double layer capacitors. Number two, pseudo capacitors. Number three, hybrid capacitor. So, on the basis of the is a storage capacity, we just divide it into the three parts, or we can classify, we can say that it is classified into the three types: electrostatic double layer capacitors, number two pseudo capacitor, number three is the hybrid capacitor. So, we will discuss briefly one by one. First is the electrostatic double layer capacitor, that is also called as a EDLC. This type of the capacitor works on the charge storage mechanism, where a charge is physically stored on the surface of the electrodes without causing any irreversible chemical reaction by the formation of an electrical double layer. Electrostatic double layer capacitor are usually carbon based electrodes and are used in the supercapacitors, which separated by the dielectric substances that act as an insulator and possesses electrical properties that eventually affect the performance of the supercapacitor. Charges are electrostatically stored in the supercapacitor. So, an electric field is generated at each electrolyte as soon as the voltage is applied across the terminal, which leads to the polarization of the electrolyte. So, as a result of which the ion diffuse through the dielectric to the porous electrode of the opposite charges. In such a way, the formation of the electric double layer takes place at the each electrode, and this result in the increased surface area of each electrodes and decreased distance between the electrodes. Now, you see on the screen, this is the electrostatic double layer capacitor structure. You see here, left hand side you are having the current collector, right hand side current collector, and we are having the active porous electrode material. By using that, this material has been developed. So, electrolyte separator is this is the separator. You see on the screen there is a middle line is showing the separator, and that is connected with the battery. So, this is the type of the electrostatic double layer capacitor structure. Now, next is the pseudo capacitor. Now, what is this pseudo capacitor? Is called the Faraday supercapacitor. This device use the electrodes made of the redox active material. What are these? Basically it is the metal oxide like MnO2, RuO2, etc. And conducting polymers we can use also for the development of the pseudo capacitors. In the conducting polymers we can use the polyaniline, polypyrols and the polythiophene. So, these type of the polymers we can use for development of the pseudo capacitor. Basically these are the these capacitor device electrodes made of the redox active materials. So, these electrodes store charge through reversible Faradaic reaction mechanism near the electrode or the electrode surface where the charges are transferred across the metal electrolyte interface. Now, you see here that this is the pseudo capacitor with specifically adsorbed ions. This is a solvent cation and electrolyte we are using here. This is a polarized solvent molecule, and then we are having the specifically we have adsorbed ions, that is a redox ions, and this is the separator we are using. This is the inner Hamilton plane. So, left hand side we are having the collector, and here we collect the charges, and that we store the energy. Next is the hybrid capacitors. These capacitors have adopted both the mechanism of the EDLC and the pseudo capacitor. That's why it is called a hybrid. Hybrid capacitors are composed of the electrodes with the different characteristics, which is based on the chemical as well as the electrical mechanism. As a result, one electrode exhibit the electrostatic capacitance and the other provides the electrochemical capacitance. So, in this hybrid capacitance we have both the both electrodes having the different, one is having the electrostatic capacitance and second having the electrochemical capacitance. So, advantages includes the higher operating voltage which increase the capacitance or the energy density. You see on the screen that this is a hybrid capacitor structure. Left hand side we are having the anode, right hand side having the cathode, and you see in between that there is a electrolyte and we use the separator. So, anion, cation and the solvent molecules are there. So, this is one type of the hybrid capacitor structure, and in this we are having supercapacitor can also be made with the different materials, and the principle at the electrodes in both of these materials use a fast supercapacitor type reaction like capacitance or the pseudo capacitance. This results called the asymmetric capacitance. The two electrodes have the different electric potential. When combined with the proper balancing, the result is improved energy density with the no loss of the lifespan and the current capacity. Moreover, in the hybrid capacitors, a number of newer capacitors are hybrid. Only one electrode uses a fast reaction capacitance or the pseudo capacitance, or the other uses a more battery like the slower but the high capacity material. For example, EDLC anode can be combined with an activated carbon NiOH cathode, the latter being a slow fabric material. The CVN-GCD provides of a hybrid capacitance have a shape between that of the battery and the SC, more similar to the SC. The hybrid capacitors have more higher energy density but have inferior cycle life and current capacity owing to the slower electrode. So you see that this is the supercapacitor. If we combine these, first is the double layer capacitor. Charge storage is electrostatically. Now you see pseudo capacitor, charge storage is electrochemically. When we combine these two, we are having the hybrid capacitors. The charge storage electrostatically as well as the electrochemically. Thank you very much.